So today is called 10.1, Lines and Segments that Intersect Circles. Last chapter was all about triangles. This chapter is all about circles. That's it. Which is great because we celebrate Pi Day at the end of the month, which deals with circles. Realistically, you're going to see circles the rest of the year probably. They're very important, obviously, in structures and things like that. But we're going to start with words and then go from there. You have two pictures of circles at the top. We're going to label the parts of a circle. Some of the words you've heard before, some of them you have not. We're going to start with the very basic of naming a circle. So what makes a circle is that all of the points in a plane are equidistant to the center. So what that means is all the way around, this distance is the same as this distance, and the same as this one, and this one, and this one. You know, that's what makes a circle a circle. When we name a circle, you can write this down. You can write down the letter P in the center of your circle. We name a circle by the center, so this one would be called circle P. Or you would draw a circle, and you would still use the center, so circle P. Either one. Usually I use the word because it's easier to type than finding a circle symbol. But it's up to you which one you want to use to name a circle. There are different parts of a circle. There are segments in a circle and lines in a circle. What do we know about segments in general? Think back to 1.1. What do we know about segments? They what? I heard it. They have two endpoints. They start and they stop, right? Whereas a line, what do lines do? They keep on going and going and going. So there are three segments we're going to talk about. Two of them you've probably already heard of. But the first one we're going to talk about is a radius. Go ahead and label your radius. Your radius. Here's just an easy way to remember it. The radius is from the center to the edge. The radius goes from the center to the edge. There's an official definition that'll pop up, but center to the edge is perfectly fine. A segment whose endpoints are the center and any point of the circle. That's a radius. You can have multiple radii. It's technically the plural form. Another type of segment is a chord. So a chord, go ahead and label your chord there. A chord goes from edge to edge. A chord goes from edge to edge. Chord, it goes from edge to edge. A diameter. So a chord is a segment whose endpoints are on a circle. A diameter is a chord that contains the center of the circle. Here's what you can say for diameter. It goes edge to edge, but in specific, what makes it different than just a regular chord? Through the center. Perfect. So edge to edge through the center. These are the three segments. So go ahead and label it. These are segments. Bless you. These are the segments of a circle. These are the segments of a circle. Here's why it matters. You're just going to need to know how to name segments. Let's say that the diameter started on A and stopped at B. When you name a segment, what does the line above it look like? A line with no arrows, good. And then you could say AB. Can I reverse the letters? Yes, so you could say BA. So all of these are segments. You would name them with a straight line. That's it. They start, they stop, and then these are their definitions. So hopefully you've heard of a radius and a diameter. Something special to know if you want to draw off to the side, you probably maybe already know this, is that the radius is half the diameter. So the radius goes from center to the edge. Diameter goes edge to edge through the center, which means it has two radiuses, radii. And obviously in reverse, that means the diameter is double the radius, both ways, which we'll talk about later on in a section. But those are your segments. Now we're going to talk about lines. All right, first one is a secant. Go ahead and label your secant. So your secant, it is a line that touches the circle twice, 2 times. It is a line that touches the circle 2 times. A secant is a line that intersects a circle in 2 points. You just need to remember that it's twice, and it keeps on going both directions. Whereas a tangent, go and look at the picture, it's already labeled. Your tangent line is in blue on my picture. How many times does a tangent touch the circle? Once. So a tangent is a line that touches the circle once. Okay? And it touches the circle at a point of tangency. That's the last part. You probably already labeled it, but make sure you label that point of tangency. It's where the tangent line touches the circle. I'll show you in a second how I remember secant and tangent. You can use it if you want. If you don't want to, that's also fine. But tangent lines are not the same tangent that you learned in trigonometry. It's not opposite over adjacent. There's no right triangle right here, right now. Think of the only word I could think of in first hour was the word record or record. They're both spelled the same, right? Record, record. They're spelled the same. They both mean different things. They're just the same word. So tangent, line, and tangent of a triangle, they're just different. They're the same word. So homonym, homophone, whatever it is, these don't really have a relationship with SOHCAHTOA like we did. But here's how I remember. If you like it, great. If you don't, find your own way. That's perfectly fine too. My first hour looked at me like I was crazy, and that's fine. Sometimes you got to be crazy. But a secant starts with an S, yes? How many times to touch a circle? Twice. A tangent starts with a T, and it touches the circle once. So S is a squiggly letter, right? And 2 is a squiggly number. Okay, and then T is a straight letter, and then 1 is a straight number. That's one way to remember. It's really the only way I remember is squiggles are together. So, very educated. I know. You're welcome. So, if you don't remember that way, that's totally cool, but you do you. So we're going to use this to name parts of the circle in this diagram here. We're actually going to name everything just so you don't look back and say, why didn't we name this one? So we're going to name, it says 2 radii. We're going to name all of them. Radii is technically the plural of radius. I don't like it, but that's what it is, just so you know. A radius goes from the center to the edge. So what is one example of a radius? AB. Make sure you put a line above it. AB. What is another example of a radius? AF. Line above it. And then the last one, AD, with a line above it. So those are your radii. There are no more of them. We're going to name, it says name a chord. Again, we're going to name all of them just so you have them all on your notes. A chord goes from edge to edge. So what is one example of a chord? CE or EC. That's a good one. DF is another. There's one more. Yeah, DE. So as long as you name it with a straight line above and no arrows, that is technically a chord. Starts in the circle, stops in the circle. Starts at E, ends at D, and vice versa. So there are your chords. Which of those was the diameter? DF. With a line above it. So those were our 3 segments. We named them like segments with straight lines. This next one is a secant. A secant is a type of line, so it needs to have arrows above. How many times does a secant touch a circle? Twice. So what will we name our secant line here? DE, sounds good. How many times does a tangent touch a circle? Once. So here's our tangent line. Here's the problem. It doesn't have a second letter, and it should have a second letter. So I'm just going to put a dot. What would let's pick a second letter. F. We already have an F. G, sounds fine. E, F, G, yep. So you would say BG with a line above. And then what's the point of tangency for that tangent line? B. You name a point. You could say point B, or you could just say the letter B. That is fine too. Questions on these?
Also, the point of tangency is where it touches the circle.
Yes, ma'am. All right, so this next portion, some people like and some people hate at first, but you'll learn the pattern very quickly. Tangent lines are we're like in the preschool level of tangent lines, and if you ever take calculus someday, we use a lot of tangent lines in calculus to find things that I don't really care about. But anyways, so if you're like, why are we learning this? It's because someday, if you had to do calculus, bless you, and you had to find derivatives and things like that, it all comes back to this. It's like when you're in kindergarten and you learn the word square, or you learn your colors, and you know what I mean? We're starting with the very basic. So, there are, if you have 2 circles, they can either intersect at 2 points, like this. They can intersect at 1 point. We're not on your pictures yet, we're just talking. Or they could intersect nowhere, where they are completely separate, or one is inside of the other. Coplanar circles, which means they're on the same plane, that intersect at 1 point are called tangent circles. They both intersect at 1 point. That's where tangent comes in. We would call this a common tangent. Okay, a line that touches both of them once. Or coplanar circles that have a common center are called concentric. Concentric means with the same center. This word isn't as important as tangent circles. We're going to talk about tangent circles right now. There can be internal and external tangents. So, a line or segment that is tangent to 2 coplanar circles is called a common tangent. You can have a common external tangent, like this one. That's an internal, sorry. Internal tangent, or a common external tangent like this one. So I'll show you why one is internal, one is external. So common internal, if I kind of outlined the 2 circles in between them, this is an internal tangent. If I outlined the outer portion of these 2 circles, that line is external of both of them. So essentially, we're going to be drawing circles that touch drawing lines that touch each circle once. So we're going to be drawing lines that touch each circle 1 time. That's it. This is why I have 2 colors. We're going to tell how many common tangents there are and draw them. We're going to use blue to indicate external. It's what I'm going to use. You can pick whatever color you want. We're going to use blue to indicate external, and then red for internal. So, again, if I outline the outside of these 2 circles, external is on the outside of both of them, whereas internal is in between both of them. We're going to start with external. Don't draw until I tell you to draw. Okay? Just going to show you the thought process. A tangent touches a circle once. We want a tangent line that will touch each circle once. So I'm just going to use this circle as an example. I'm going to go around putting random dots, and we'll talk about if that line would touch the other circle 1 time. So let's start with this. Would this line ever touch the other circle? No, so it's not a tangent line. I'm going to move over. Would this circle or this line ever touch the other circle? No. Would this line ever touch the other circle? Yes. Go ahead and draw this one. This is one of the common external tangents. If I keep going around the circle, keep envisioning, this is in between. You see this white space? So I'm not going to draw in between here because those would be internal tangents. We're trying to find external tangents. So can I draw a line from this circle to the other? Can I draw a new tangent line? Yes. It'll look pretty much identical to the other. And then I would be on the back of the circle again. So there are two external tangents. You're going to see the pattern. I promise you it'll be okay. I promise. I'm going to use red to indicate internal tangents. Internal mean they'd be on the inside, so the inside would be in between them both. So remember that you want a line that touches both circles once. So if I started in the center, would this touch both circles once? No, but if I do at an angle, it will touch both circles once. So you can go ahead and mark your first internal tangent. Just do the best you can. I'm not super picky. So where would my other internal tangent be? The other direction, yeah. Ta-da! Ooh. Just do the best you can. So we have two internal as well. It does say tell how many there are, so that's why we listed them. You will see this pattern a lot. Really what will change is the amount of internal tangents, not necessarily the external. I'll show you here on B. How many external tangents will we have? 2. So same idea. So we'll have 2 external. I know this one looks tricky for internal. We want one line that touches each of them once. These circles do touch, we all agree. They technically touch in one place. So our tangent line, our internal, will touch in that, or that go through that one place. So it'll have one internal tangent line. Letter C, how many external are there? 2 again. Bless you. So 2 external. So for internal, is there space in between both circles? No. If I drew a line, this would be wrong. If I drew a line, how many times would that line touch both circles? 2 times, which would be a secant. So there aren't any internal. You can list that if you want, but it says how many that there are. So like you don't have to say that there are 0 internal, because it says how many are there. Yeah. You won't use 2 different colors on your quiz test. We're just talking about internal and external in this part because you're going to practice on this one. So you're going to tell how many tangents there are and draw them. And then the second part is you're going to tell me whether they're internal or external. So this is in the middle of the page. You're going to answer, and then we'll check it really quick. So, how many common tangents are there? 2, and where are they? They're external. So 2, and they're external. Should look like this. So you'll catch on. The only situation you haven't seen is a situation like this. You see how the circle's inside the circle? So this would be no tangents at all, because if I tried to draw a line that touches one of the circles once, how many times would it touch the other circle? Twice, which would be a secant. So that's the only situation you haven't seen. That's the only new one. So if you want to put that, you can remember that it's 0 external and 0 internal. But, so now we get to like the math portion. Like we're going to do real math. This is why you have a calculator. I would probably find a section, maybe under that last picture, like draw a box or something where we can put in a concept that is pretty important to this section. So just find space, draw a box, and I'm going to have you highlight it because it's pretty important. It's the hardest math that is in chapter 10 until 10.7. So here's what's going to happen. It's going to ask, is this a tangent line? So are we allowed to say in geometry it looks like a tangent line, so it is a tangent line? No. So we have to either decide if it is or is not. So essentially, all tangent lines, the tangent and the radius, this is what you're writing in, the tangent and the radius, we'll say need to be perpendicular. So the tangent line and the radius need to be perpendicular. I'll write that in that box. You're going to see it in the next two examples. It's going to ask you to explain on a homework assignment or a quiz or a test. And this is what it's going to come back to, is the tangent line and the radius, they should be perpendicular to each other. What does perpendicular mean? They intersect in 490 degrees. So we're going to decide if this line is tangent, if line M is tangent, by seeing if it is perpendicular to the radius. Okay, so we'll see an example here. This is on your paper. Is ST tangent to circle P? So ST, go ahead and mark that. Oops, sorry. ST, go ahead and mark it as our tangent line. Is it perpendicular, is it tangent to circle P? If it is tangent, that means that ST would be perpendicular to the radius. Which of these is the radius? Which one? TP or PT. This would be the radius. So if it is tangent, there would be a right angle right here. Because tangent lines will be perpendicular to the radius. There will be a right angle between the tangent and the radius. So we need to figure out if there is a right angle here. What shape are we looking at? A triangle, but what kind? A right triangle. We need to figure out if this is a right triangle. How do we figure out if this triangle is a right triangle? We're going to use the Pythagorean Theorem. So a squared plus b squared equals c squared. If they equal, what kind of triangle is it? A right triangle, which means there's a right angle there. If they do not equal, then it's not, not tangent. So which of these is going to be C? 37. So this is C. And then 35 squared and 12 squared. We all know 12 squared is 144. What is 35 squared? Perfect. 1225. And then what is 37 squared? 1369? Yeah. Perfect. So add 1225 and 144. What does that make? 1369. So these equal, right? So is ST tangent to circle P? Yes. I'm going to guarantee, though, don't finish the problem. I'm going to guarantee on your quiz and test it's going to say explain. And I love you guys, but a lot of you skipped. It said explain your reasoning on 2 questions on the test, and a lot of people skipped that part. It was very interesting. But when it says explain, here's what your explanation is. Because the tangent and the radius are perpendicular. You could say because they form a right angle. You can say it in other words as well. But your main thing is that the tangent and the radius are perpendicular. Questions on your explanation? You're just using the definition to explain your reasoning. Perfect. We will do it again, however, slightly different. This is the hardest question we're going to have. If you struggled in Algebra 1, this might be a little more difficult for you. But I do remember the last section in your Algebra 1 book does something similar to this. So, in the diagram, point B is a point of tangency. So, are we questioning if we have a tangent line? No, we have a tangent line. Which one is the tangent line? AB. Go ahead and mark that it's the tangent line. And we're going to find the radius. So before we even start that, if this is a tangent line, the tangent and the radius are perpendicular. So that means that angle B is a right angle. Is everyone tracking? We know this is a tangent line, which means we know there's a right angle between the tangent line and the radius. So this is still a right triangle, yes? Perfect. So we are still going to use the Pythagorean Theorem. A squared plus b squared equals c squared. The only difficult portion will be C. Not even difficult, it's just different than what we've been doing. C is AC, correct? Is 50 the full length of C? No. It's also not the longest side. 50 is not the biggest number here, right? AC is 50 plus whatever the radius is. We all tracking here? It is 50 plus the radius. So this is what we're going to plug in as C. 50 plus the radius. If you notice, I put it in parentheses. It's because that whole side length should be squared. Whatever 50 plus the radius is should be squared. So what are my A and B? 80 squared and r squared. So this is what I meant by algebra. From here, we are just doing algebra. What is 80 squared? 6,400. R squared is just r squared. What is happening when you are squaring a binomial like this? What is happening when you square anything? You're multiplying it times itself. So essentially, this is 50 plus r times 50 plus r. Addison, you're right. That's the next question. So we're multiplying it times itself. Is everyone okay with this? So the left side will stay the same. Haven't done anything with it. The right side, we need to multiply these two together. There is a fancy acronym you can use, or you don't have to use. Does anybody remember the acronym? We're going to FOIL. Essentially, you're just going to distribute and then distribute. So if you don't remember FOIL, FOIL is first. So multiply the things first together. 50 times 50, 2,500. Outer means 50 times r, which is 50r. So essentially 50 just got multiplied times both of these. Now we're going to do the same thing with this r. We have inner, so r times 50 is 50r again. And then we will have last, which means r times r, which is r squared. I'll save us a little bit of writing. R squared is the biggest term here, right? So normally you try to move them to try to solve for that. But if I try to move r squared, what would I have to do? I'd have to subtract it. But if I subtract r squared on both sides, what happens to both of them? They cancel out. So you can just go ahead and work. We're going to go ahead and do that in one step. We're still going to combine like terms. We have 6,400 on the left. On the right, we have 2,500. And then what is 50r plus 50r? 100r. So we just keep solving for r. Subtract 2,500. What is 6,400 minus 2,500?
39.
Yeah, 3,900. Equals 100R. Divide by 100. Hopefully you can figure out what R is by now. R is 39 feet. We'll say this is the hardest question until like the last thing we learn on 10.7. So we'll practice a lot. The main thing that I see people get wrong is, this section right here, the foiling and things like that. But we will practice a lot. The last thing we're going to do is this example. Tangent segments that have a common external point are congruent. So here's what that means. We have SR is a tangent. ST is a tangent. They both intersect externally at S. So that means their lengths are going to be congruent. So congruent means that they are the same measure. So what's going to happen is RS is tangent to circle C at S. RT is tangent to circle C at T. Find the value of X. They both are tangent and they both intersect at R, which means they are the same length. So what can I do if they're the same length? Set them equal. 3x plus 4 will equal 28. Subtract 4. 3x equals 24. So then x equals 8. So you're going to take out your whiteboard and your marker. We'll start with easy stuff and then work our way up. You can keep your notes out to reference. I probably would recommend it. We're going to start with this one. Name 2 radii and 2 chords. Two radii and 2 chords. Yes, sorry. Yes, sorry. I hadn't memorized the second question yet. Yep. Yep. Correct. Both of you are correct. Yes. Yes. Good. So our 2 radii are EC and EF. You name them with the line above. And then our 2 chords were BD. And where's the other one? And CF. Good. Tell whether AB is tangent to circle C. Explain your reasoning. So this is similar to that question on number 2 and 3. Number 2 mostly, page 2. And then you have to explain. Good. Perfect. Yes, ma'am. Nice. That's good. All right, so how would we know if AB is tangent? It needs to be perpendicular radius, right? Which are we calling the tangent? Which line? Yeah, AB or BA. And then which would be the radius? CB. So we want to see if there's a right angle there. We do that by the Pythagorean Theorem. So you'd plug in. This ends up being yes, because the radius and the tangent are perpendicular. So there's that question. Is that what? Okay. And this one, points B and D are points of tangency. Find the values of x. So similar to that last question, most likely. Correct. 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 So what do we do with these two? Set them equal. So what do we get for x? 5. Good. All right, here's the hard one. B is a point of tangency. Find the radius of circle C. That would give yourself a lot of room on your board if you write large. Correct. Correct. Good job. That's correct. 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 So you want to set it up like this? Did you already erase it? Who did not erase it yet? You did not. So this square should be on the outside, not on the inside. All of it should be squared. You look like you're doing good. So you're foiling. This should be r times r is r squared. Where did you get this r from?
I have no idea.
Okay. I think the r squared is gone. So I don't think this should be there. I'll give you a few more minutes to figure it out, or a minute maybe. What was 23.04 minus 12.96? 0.04? Okay. Okay. So we got the radius to be? Correct. 1.4. If you did not quite get it yet, don't erase your board. I want to help you. Here's the next question if you did get it. All right, what do we get for our diameter? FC. What kind of line should you have above it? One without arrows. And then your secant with arrows. I think there's only one answer. It's BD. Why is this one not a tangent? Doesn't have arrows. Doesn't keep going, right? And then it says name a tangent line. So that would be, well, tangent line. AH, or you could say HG, or you could say AG. Those are all the same. And then what is the point of tangency? H. Make sure you answered both parts.